Chapter 15, Freshwater Systems and Resources. This case study is about Louisiana and sediments and wetlands. So the paragraphs here show the benefits of wetlands and the benefits of sediments and the problems with levees. So make sure you know for your test why wetlands are so good here and why sediments that are brought down from the Mississippi River to the Gulf of Mexico and all the wetlands, why those sediments are good. And then levees are built along the sides of the river to prevent flooding, but it also prevents sediments. And so this is a problem. And so these are the problems with the levees. The figure and caption here shows the loss of our wetlands due to the loss of the sediments that build up the wetlands. And you can see here how it's changed over time, which makes this area more vulnerable to hurricanes because all of this land would help diminish. As the hurricane hit land, the power would go down, the energy in the hurricane would go down. But now with diminished wetlands, a hurricane that hit New Orleans, Hurricane Katrina, was extremely damaging because of the diminishing wetlands. All right, know the stats here about fresh water. Basically, only 2.5% of the earth is fresh water. Most of it is locked up in ice caps and glaciers, and so really we only have about 1% of all the water in the world is available for us to use for drinking, for agriculture, and for industry. Know all the bold terms on this page, what freshwater means. Surface water is a stream or river on top of the surface. Groundwater is under the ground. Aquifers are a groundwater. A confined or artesian aquifer and an unconfined aquifer. Know them all. Okay, on this page, oh well, first of all, this picture is really nice because it shows you all the different types of water here. And how it meanders into a salt marsh and how pollution affects water and pesticides and all of that good stuff, or bad stuff. All right, this figure and caption here shows you how aquifers are recharged. So basically groundwater is an aquifer, and sometimes it bubbles up into a spring and makes a little lake here. You can dig down and get wells to get the water. So people who have well water, they have pumps that pump it up, and that's what they use for their homes. And so when rain falls and soaks into the ground, it recharges aquifers. But not everywhere, because some places have bedrock that the water can't soak through, and so other places do not. And so they'll go right into the ground and soak in. The largest aquifer in the whole world is the Ogallala Aquifer. I know it's a funny word, but it's the largest in the world, and it's mainly in Nebraska and these states. Really important that you memorize these terms. Now they are in italics, but they're super important. Runoff. A tributary is a river or stream that runs into a bigger river. So it's like a stream that runs into a river. So in other words, around here, Bouquet Creek is a tributary of the Santa Clara River, because Bouquet Creek flows into the Santa Clara River. A river system, what a watershed is, what a floodplain is, and what riparian means. Riparian means having to do with a river. So riparian ecosystem is a river ecosystem. Okay, so we've studied eutrophication, mainly in the ocean, but it also happens in lakes as well, but it's a little bit different. So a eutrophic lake means you have more nutrients come in, but it causes plants to grow. So you remember, lakes freshwater, you can have plants, not just plankton. Well, the plants fill up the lake and choke it out, and so you can't really have your fish and things. They don't have enough room. You need to know the definition of oligotrophic, which is the opposite of eutrophic. So a oligotrophic lake looks beautiful. It's crystal clear. It looks so pretty, but it's actually devoid of life because they don't have nutrients, therefore not enough plankton or plants. They have high oxygen, but very little life. On this page, know the definitions for the layers of your lake. The littoral zone, which is kind of this area near the shore. Your benthic, which is on the bottom. Limnetic, which is kind of the light zone, and profundal, which is in the middle. So know these zones of your lake. On this page, know what a wetland definition is: a swamp, a marsh, and a bog. These are kind of all synonyms for wetlands, but with some variation. So a swamp that looks like this, or a wetland with these characteristics is a swamp, and then different characteristics is a marsh, and different characteristics is a bog. So wetlands have huge benefits and ecosystem services. Make sure you read and memorize this paragraph here for why in the world wetlands are super important. We have threats to wetlands as well. We fill them in because they're wasted land, right? They're not. We develop on top of them houses or agriculture. We build roads and bridges over them, which cause air and water pollution into the wetlands. And then we have some issues with invasive species. Kind of a big example is the snakes, the Burmese pythons in the Florida Everglades wetlands. They have issues with snakes there, invasive Burmese python. Okay, page 397. On this page, we have a paragraph about how the Colorado River fails to reach the ocean in the Sea of Cortez, right between Baja, Mexico and mainland Mexico, or Baja, California and mainland Mexico. And so this reduction in flow, so much is diverted to cities and agriculture in California and in Arizona and Colorado, etc., that it fails to reach the ocean and the problems that it causes. So make sure you read and understand this. Consumptive and non-consumptive use. Consumptive use means that it's used up, like it's watered for crops or we drank it. Non-consumptive means we used it, but it can still be used for other things like hydroelectric power or even your shower. Your shower is not consumed. It goes down the drain and can be used, cleaned up and used for other sources. So that's non-consumptive use. So the Aral Sea has been depleted so much and so quickly that actually they didn't even have time to move all the ships away. So know about the Aral Sea. It's a good example of water diversion. So if we pump too much groundwater, we can get sinkholes or a sinking chapel in Mexico City or sinkholes, and we have them kind of everywhere in the US and other places too. All right, so this page here on page 400, is it better in a bottle? Is bottled water safer? The answer is no, it's not. So these stats on this page show you that bottled water has little regulation compared to tap water. Bottled water uses huge amounts of energy and fossil fuels to make the bottle and to bottle the water. 60% of bottles contain endocrine disruptors. So they are not safer. All right, page 401. You can take that how you want to take that. So dikes and levees prevent flooding to save farms, homes, and properties. So these are like where they cement the sides of rivers or lakes. So they prevent flooding, which prevents economic loss, which is good. But when you prevent flooding, you also prevent bringing sediments and nutrients to farms. So the best farmland has always been near rivers because of flooding and nutrients. That's where Lombardi Ranch is in town. It's right by Bouquet Creek. So the flooding of Bouquet Creek initially provided the nutrients for the farm. Know what an aqueduct is? We have one right next to us in the pipe behind our school. So an aqueduct is a man-made river to carry water from one area to another. The LA Aqueduct is next to Saugus High. That's not our water, actually. It goes through our town to LA City for their water. Our water in Santa Clarita comes from a different aqueduct called the California Aqueduct. And so we use aqueducts extensively in Southern California to get water from either Northern California or from the Colorado River. We do not get Colorado River water in Santa Clarita. That goes mainly to Orange County and Palm Springs and San Diego County. Page 403, know here all the positives and negative impacts of dams and reservoirs. So the positive things are in blue and the negative things are in orange. So positive things is we store water, which we can use to drink and for agriculture and for recreation. We prevent flooding. Those are good things. Bad things is when we flood this area, people who used to live next to a river, basically we turn a river into a lake when we build a dam and we flood the area behind it. People were displaced building the dam. They always are. There's a small risk of failure. The habitat is disrupted, so now your river species go away and then lake species come. Recreational for rivers, like whitewater rafting, goes away. And then fisheries decline if you block the migratory route of salmon and trout that migrate up rivers to spawn and breed. That's a problem as well. So you also have more warmth here, buildup of warmth compared to a cold moving stream. So we have, a positive is renewable energy through hydroelectric dams. So we have positives and negatives. You need to know about the Three Gorges Dam. Here's a picture. It's actually a really ugly dam, in my opinion. That's just, my opinion. It's the world's largest. They finished it. It basically flooded huge amounts of land, including archaeological sites. They had to remove 1 million people from their historical and ancestral villages and farms to cities because their villages are now gone underwater. So in some places that we don't need the dams anymore, we are removing them for these reasons: to restore riparian habitat, that means river habitat, to provide recreation, and also to help the salmon with their spawning. So we've done this a lot in the Pacific Northwest. Well, actually not a lot, just a little. It's starting to get momentum, actually. All right, so desalinization plants. So a lot of people with our drought are like, we need to build desalinization plants. That is an E, not an A. Desalinization plants. Turn salt water, so we could turn our ocean water into fresh water. Can't we? Isn't that super easy? Why can't we do that? It's complicated. So desalinization plants use a lot of energy, and it's usually fossil fuels because we don't have the technology to create huge amounts of energy with photovoltaic cells or windmill, enough to really turn the salt water into fresh. So we're going to burn fossil fuels, which causes air pollution and climate change, all that stuff. The types of desalinization is distillation, filtration, or reverse osmosis, and those are different types of processes. It produces a salty waste. We have to get rid of this brine, which is usually hazardous waste, and truck it somewhere where we can dispose of it or pump it underground. It kills aquatic life. They get sucked up into the plants and die. A lot of plankton or small critters or larvae. You also need to know that they're very common in the Middle East, like Saudi Arabia, because they're a desert, but they have a lot of cheap oil. So basically they burn the oil to desalinize the water. And we'll continue on with the next video.